problem 9.9. Here we need to design an aerated grit chamber. Remember, as we mentioned in the lectures, that the grit chamber will remove only the inorganic grit. Of course, if you have aeration in the grit tank, there's a blower that will allow air to come into the tank, and you can see that air bubbles, and this will help the grit settle to the bottom of the grit chamber, and then here you will collect all the grit. And of course, before before the wastewater enter the grit chamber, you will have a screen to remove any large object. So this aerated grit chamber is to treat a 1-day sustained peak hourly flow, 1.6 meter cube per second. This is the peak hourly flow. The average flow is 0.65 meter cube per second. First of all, he wanted to determine the grit chamber volume. What is the grit chamber volume? Assuming there are 2 chambers that will be used. So we're going to use like these, 2 of those. Okay, so we will be using the peak hourly flow to find the volume. And before we start this, we need to determine the detention time that is needed in order for this grit inorganic solids settle to the bottom of the tank. So how much time, how many minutes, how many seconds that this grit will stay inside the grit chamber before it is removed. So we need this design information that's used to size and aerated grit chambers. This is for designers, and the detention time needed should be between 2 and 5 minutes. So we're going to select something in the middle, 3 minutes. Okay, of course, if you select 2 or 5 or 4, that's still acceptable, but in the exam the detention time will be given, because we need to check your answers, and the answers has to be universal. So the total grit chamber volume is by multiplying the peak hourly times detention time assumed, 3 minutes, and of course minute to second. So minute will cancel with minutes, second with second, and you'll end up with 288 meter cube, and that is the volume, total volume of grit. Now we have 2 chambers, so the volume of each grit chamber is, you divide this by 2, because every chamber will have a volume of 144 meter cube. Okay, so we are done from this. Let's look at the second part. What is the dimensions of the 2 grit chambers? Now the dimensions, we have to find out what is the length, what is the width, and what is the depth. Okay. When you go to the design information for sizing aerated chambers, you have to look for the this width to depth ratio, 1.1 to 5.1. 1.1 to 5.1 is, of course, should be in the range, and we should assume this it's 1.5 to 1. This is the width, and this is the depth. Okay, and this is the ratio. Now this is the width, this is the width to the depth ratio, so it's W over depth, just to simplify it. And now the depth should be selected from the design information, 2 to 5, and let's select something in the middle, 3 meters. Okay, so the dimensions of this is the grit chamber width, the grit chamber width. Remember, you have width over depth is equal 1.5, and you have the depth, so the width is equal 1.5 times the depth, and the depth was assumed 3 meters, so 1.5 times 3, the answer is equal to 4.5 meter. 4.5 meter. So we have the width and we have the depth. Now what is remaining? The length. So the grit chamber length, the grit chamber length is equal the volume over the width times the depth. So what was the volume? The volume was, if you look at it, of course we have to look at each chamber, not the total, 144. What was the width? 4.5. And what was the depth? 3 meter. And you'll end up with 10.7 meters, which means that the length of, if you look at the chamber, the rated grit chamber, it will be something like this, and you can see that the width was 4.5 meter. This is the width, and the length is 10.7 meter, and the depth was 3 meters. So this is the design of this is the second part, which is dimensions of the two grit chambers. So each one of the grit chamber will have the following dimensions. Now let's look at number C. What is the average hydraulic retention time in each grit chamber? Okay, so let's erase this and try to find C. Okay, so we'll look at number C, the average hydraulic rotation time in every grit chamber. And for this retention time, we need to use the average flow rate. Remember that we have two flows. There is the peak hourly flow rate, and there is the average flow rate. So for C, and since we are dealing with we need the average hydraulic detention time equal the volume over the average. Remember, the average, it was 0.65, but this 0.65, it is for both, so we need to divide by 2 because we have two tanks. So the volume, let's look at the volume. The volume, it was 144, and this is the volume of each chamber divided by the average flow, 0.65, and that's for both, so divide by 2 for each tank, and this will give you the, remember that 144, it was in meter cube, so let's put this in meter cube, and this one is meter cubic per second. So meter cube, and then you have second at the top. So you'll have second and minute, 1 minute 60 seconds, and then you could cancel out second with second, and then you'll end up with 7.4 minutes. This is what? This is the average hydraulic detention time. Let's look at number D. Number D, what is the air, how much air is required? Assuming 0.2 meter cubic of air per meter length of tank per minute. So the assumption here, the air requirement, you remember he took it from here, it is 0.2 to 0.5, so he took the lowest requirement of air, 0.2 meter cubic of air per meter per minute. So this is what he assumed here, but you could take his assumption and find out the air requirement. So assuming taking the 0.2, now we are solving D, 0.2 meter cubic per meter per minute of air. You multiply it by, this is by the length, because remember the pipe will be based on the length of the tank to allow the air in. So this is times 10.7 meter, and then times 2 tanks, because you need to apply the air for both tanks. So 2 tanks times 10.7 times 0.25, so you'll end up with 10.7 okay, so you'll have it like this, 10.7 times 2 times 0.2, and that is 4.28. So this is what we're gonna have as total air requirement, meter cubic per minute. So of course this assumption, that was the book assumed. You could assume something else, but I will give you the assumption of the air requirement. Okay, number E. Number E, the quantity of grit removed at peak flow. How much grit is being collected here at peak flow? Assuming a typical value of 0.2 meter cubic of grit per 1,000 of meter cubic of untreated wastewater. Of course, this is the quantity of grit is assumed here 0.004 to 0.2. So he selected the highest, 0.2. Okay, so how much grit is being disposed or removed at the bottom of the aeration tank, at the bottom of the aerated grit chamber? You can see grit volume. This is equal the peak 1.6 meter cubic per second, and then you multiply it. What was the things? It's point, solve the amount. Okay, 0.2 times 0.2 meter cubic of grit per 1,000 meter cubic of grit per 1,000 meter cube of water. This is of grit, so this is what this is, will be cancelled, and you'll have second and minute, and then we should make it 160 seconds, second with second, minute with hour, hour with day, and I think we needed to do it in days. So 1.6 times 0.2, 1.6 times 0.2 over 1,000 times 60 times 60 times 24 over 1,000. So the grit volume that will be disposed is 27.65 meter cubic of grit will be collected or will be removed per day. Huge amount of grit that's being removed every day. So this is the end of this example.